Hi, this is Mike Morrow, and I'm going to do my presentation on National Robotics Initiative 2.0, Ubiquitous Collaborative Robots. In this presentation, what I'm going to go over is I'm going to start off with the overview of the NSF proposal, which is the National Science Foundation. I'm going to talk about and evaluate the SDLC models, or Software Development Lifecycle Models. And I'm going to talk about just the database and project management teams. There are more teams that came together to develop the proposal for this project. But in this presentation, I'm only going to focus on the two teams I was involved in because I simply do not have knowledge about the other teams that I would be willing to put in for this presentation. So to talk about this proposal, the NSF, stated that, robots are developed to help people to assist in their daily routine. As you know, robots aren't some sort of science fiction thing. It's an actual unit, and it's no longer something that's only, like, say, rich people or large corporations can use. These robots are out there to help us to assist in our daily lives. Like if you look at Honda and Toyota, I don't know if you ever see like those robots that can move about, and these are the kind of things that over time will develop to help us assist people, like in maybe just disabled, help them get things like cook food or even get the mail, help even greet people, to in a corporate environment where factories are using them to assemble cards or very intricate with devices, and even in surgery because the robots are more precise than the human hand. And what this program will do is they're requesting more research and other techniques to basically build upon that. We want to keep pushing for more research to help these robots, basically scalability and usability, so they can be no longer something only a rich person can afford, but something that everybody can take advantage of in their daily lives. And so in order to do this, we're going to create a virtual lab. And the idea behind this is there's going to be basically a website that's going to facilitate the user with the robots. So the user will be creating an account, and that they'll use to able to request an appointment with a robot, and there'll be personnel there to verify appointments so that the person can interact with the robot. And these robots are going to have many sensors on them, including like pH levels, chemical content in the environment, sound levels, and things like that for the user to record. And of course, the user can create code like C++ and Java code, upload it to the robot to do more special tasks. And the user will be able to see what the robot is doing and stream it on the website so they can fully see what it's doing. There is going to be a database involved. This is going to be used to store user accounts. It's also going to track user lists, social media lists, and it's going to store all the data that was recorded from the robots for the user, like for research or whatever. There will be a social media component to this. We kind of want to spread the word, have, tell people out there, hey, we got this really cool program where you can interact with robots. All you gotta do is have an account, and if you want to, you can even put code in there, and it could be fun. You can kind of play around with the robot and see what they see. Hopefully get something out of this. Now, security will definitely be implemented because this is, pretty serious stuff. There's definitely going to be physical security, so there's going to be access cards, cameras, and so on. And we're gonna have definitely security for the code that people will upload to these robots, because that's definitely an easy way to, let's say, to upload malicious code to a robot and do whatever, corrupt it or even use the robot as some sort of passageway to get into the main network infrastructure for this virtual lab. So in order to go about making this virtual lab, we're going to talk about some of the SDLC models that I've considered for the development of this virtual lab. So we're going to take a look at the waterfall, spiral, agile, object-oriented analysis design, or OOAD, rapid prototype, and the diamond model. As you can see, is bolded. This model is something I created to basically eliminate all the disadvantages from the previous models that are listed on this slide, which would be fantastic for anyone for developers, and of course this will help people not have to choose do I want to use a waterfall for this or spiral and so on. So we're going to start with the waterfall model. The waterfall model was developed by Dr. Winston W. Royce. However, Barry Boehm, which we'll talk a little bit when we get to the spiral model, claims that it was actually made from good approximations by Bennington and Heuser. And of course, as the name suggests, the model flows down like a waterfall, and then I'll show you a picture of it in this slide here. And as you can see on the waterfall model, you have your requirements, design, implementation, verification, maintenance phases. And as the name suggests, you start from the top and you just go down and cascading just like a waterfall you see in nature. And we're going to talk about the phases of the waterfall model. You have the requirement phase, which is just gathering requirements from the client. These requirements would be, like let's say for this virtual lab, basically the document suggests that we are looking forward to develop a way for people to interact with robots. So that's where the whole virtual lab idea came from. The design will be to develop the system based on those requirements. So that will be basically putting together all the components like the database, security, social media, and project management, so on, to the project. Then the implementation is when the system will be ready to be deployed for actual use. The verification, will be deployed to the client, and the maintenance phase will be to basically correct any issues that arise from the client. And I want to make one note before I forget: the implementation phase is when you test and deploy the system. Forgot to note that. So we're going to talk about some of the pros and cons of the waterfall model. Pros would be it's easy to understand. As you can see in the picture, it just goes down. Simple as that. And it's great for small and short projects because with this you can, since it's very simple, and especially if you know all the requirements that you need for this for any project, the waterfall model is great. If you got all your deadlines and you know what's going on, you have an idea in your mind, I'm going to implement this, maybe your own software or somebody else's software package, the waterfall model is great for that. However, there are some cons with it. There's no risk analysis, so there's really no way you can check and see if is this project really worth doing, or is it worth it can be cost too much money, is the time extremely short, is it feasible, is the data you have corrupt, is the clients you're working for not doing anything, things like that. So the best time to use the waterfall model would be for small projects, and then if you have requirements that are well defined and easy to understand from the client. The next model we're going to talk about is the spiral model, which was developed by Barry Boehm in 1986 while he was working at Thompson Ramo Woodridge, or TRW, which is an aerospace company. It's an incremental model, which meaning is that basically as the phases progress forward, you're building upon the system or software that you're developing for the client. The model moves in a spiral motion, as the name suggests. Just think of like a spiral just continuing going around and around. That's simply how the spiral model moves into each phase. And then the spiral model is actually divided into 4 quadrants, which we'll discuss in the next slide. And then here is a photo of what the model looks like. As you can see, you have the 4 quadrants. You start from the top left, determining objectives. Then you progress to the identify and resolve risk. Go down to development tests. And then you get to the 4th phase. You can either release the software system to the client, or if the system is not up to the client's requirements and specifications, you go ahead and continue with the spiral. So the phases of the spiral model, you start with the objectives. This is where you gather your specification requirements from the client. And this one here, I think is really important with this model, is identify risks. So with this, you can, analyze, things such as cost, time, data, if they're feasible, if it's worth using or not. You can analyze these risks in this phase. So if there are no more risks in this phase, you can go ahead into the development test phase, where the system is going to be developed and then it's going to be tested before it's deployed. And in the last phase, you can go ahead and release the system, or if you have to continue with the system. So some of the pros and cons for the spiral model: it's great for handling large systems because you have a lot of time to do risk analysis, and you could keep running multiple prototypes of a system. Good documentation, so you can keep track of everything really well. And of course, risk control, it's definitely a really big advantage. You don't waste all your time and money, we realize that this project's not even worth doing. Some cons for the spiral model is you definitely need to have some knowledge to identify risk. Sometimes you may not realize there's a risk involved until you actually deploy it. So you have to have some staff or developers, whoever, with some really good expertise, and they could really identify a risk when they see it. And of course, the costs. You can think of a spiral; it just keeps going around and around and around. So will it ever stop? You could really run out of money in development time with the spiral model. So the best case to use the spiral model would be, handling large systems, and of course with complex requirements, because you could basically go around a spiral, especially in the risk phase. If you realize something's out of place, this model is a great way to be able to check if the requirements are valid or not. So we're going to go ahead and talk about the Agile model. This was developed by a group of software developers in Utah in 2001. It's a incremental model, and it has multiple iterations, so you can have multiple teams working on the same project. And this is a photo of the spiral model. As you can see in this example, they have 3 iterations going on, or basically I think of it as like 3 teams, and they're all building on the same thing. So here's some of the Agile model phases. Planning, you gather requirements from the client. You have the requirement analysis, so you analyze those requirements, see if they're worth it or not. And you have your design phase, where you can go ahead and code the system. And then your coding is when you're actually developing in the system. Unit testing is you're testing, make sure everything is correct, and you're going to go ahead and ready to deploy it, which will be acceptance testing. You give it to the client and to verify that the client agrees with the system you developed for, and they will accept it. So here are some pros and cons for the Agile model. It can accept late requirements. You get multiple teams running loops around each phases, so you can go ahead and absorb any requirements that have been thrown at you from the client. And of course, with this model is that you have close communication with the client and developer, so you could pretty much consult the client before you just, here's the system. Now where's my $200,000? Some cons with the model is like documentation. If, let's say, a member of the team gets promoted, fired, or quits for personal reasons, and you have to find a replacement developer or whoever, you know, they have to be run up to speed on what's going on. And this model does not provide much documentation between the phases, which can be cause delay and even money if when you have to train this person and get them up to speed of what's going on. And there's issues with novice developers communicating with the senior developers. Like I said, it's just you. If you get someone who's new, unfamiliar with what's going on, it's just they're gonna have a hard time catching up and realizing what's going on. So the best time to use Agile would be, if you have a project that's always getting different requirements from the client, this model is great for that. And if you have a decent sized company or group and you can divide those people up into teams, this model supports that very well. Next, we're going to talk about the object-oriented analysis and design model. This was founded by Rational Software, which they were bought out by IBM. And this model is kind of like, I always looked at it as like a C++ program, because you have objects to represent customers, suppliers, contracts, or whatever. And a popular model with the object-oriented model is called the Rational Unified Process, or RUP. And this is an example of what the RUP model looks like. As you go, you have on the x-axis you have time, and on the y you have resources. So as time goes on, you're going across each of the phases: inception, elaboration, construction, and transition. So in the inception phase, you have to gather requirements, and you also analyze risk and determine feasibility from the client, which is, I think, a really good thing. And for elaboration, you go ahead, take those requirements. If they they went through the analysis risk and everything's fine, you go ahead and develop the system from those requirements. And you have the construction phase, which is when it's actually going to be developed and tested. And then transition is when you deploy the system to the client. So there are some pros and cons with the RUP model. There's explicit pros is explicit recognition of deployment activities. So you kind of the client knows like what's going on when you're developing the system, and it's component based. Some cons of the model is IBM owns them, so it could cause issues with copyright, or even you have to buy software from them to develop the system. And one size fits all is, I feel like the model tries to accomplish a lot of things, and which may not scale well for like smaller groups, especially if you have to get software from IBM to construct this model. That can get pretty pricey. So the best time to use the RUP model is for a medium to large project, and if you have a really skilled development team, this would be great to use the RUP model. Next, we're going to talk about the rapid prototyping. Rapid prototyping is one of the methodologies of the Rapid Development Model, or RAD. And this was developed in the 80s to meet software development demands. At that time, 80s and 90s, we were really, computer technology was getting better and better. So you had all this raw horsepower that you can use for to develop software. So you need a model to basically support this rapid change in technology. And this model also provides a tangible solution to the client while the development team is gathering all the specifications and requirements. So at least you can actually give something to the client and say, hey, this is what we developed, you like it or not, and then you can get their feedback, and then you can take that information and keep developing your project. And this is a picture of the RAD model. You start from requirements planning, and as you go down, similar, kind of like the waterfall model, but with this, you can actually go back between, consult previous phases, which is really a very useful thing. So you can kind of make sure before you move forward that everything that you've done previously is up to spec. And we're going to talk about the phases of the RAD model. You have a requirements or planning phase. So you work with the client to gather the requirements for the project. And you have user design phase. This is when you kind of analyze the requirements and you present like a design to the client. And if they agree with it, you go ahead and move on to the construction phase, which is when you actually take those requirements and you make a design out of it. And the client is included in this as well. So that's very useful for the developer. And that way you don't have to say, hey, this you have to talk to the client, and you say, oh, the client doesn't like it. You have to go back and spend more time and money on developing something. And now in the cutover phase is when once everything is fully developed and the client agrees with the system you develop, you can go ahead and deploy it to them. Some of the pros and cons of the RAD model are, with the pros, you work with the client on the system, so you're constantly communicating with them and make sure everything is progressing well. And since there's only 4 phases in the model, it's not going to cost as much time and money, so that helps a lot, especially if you're a smaller developer. You may have to be a little more cautious on keeping time and money in check. Some of the cons of the model are you do have to get case software. That's computer-aided system and evaluation tools. That could be pretty expensive to purchase. There are free ones out there, so it's kind of it can be really expensive, or you can find a good cheap one. Hopefully it's a really good one, but that could cause some problems. And there's really no risk evaluation, even though you are talking with the client. There's really no phase that sets aside, hey, is this project feasible? Is it worth developing? Is data any good, or is this client nuts, or whatever. And now we're going to move on to the diamond model. Now this is the model that I made, and like I said earlier, the biggest advantage to this is eliminating all the disadvantages from the other models. And this is it here. As you can see, you start from the left and you go up on the incline as the arrow points to the 1. And so you start with requirements, specifications, you go into risk, prototype, test, and release. So if you get to that top there, and let's say the system is not ready for client, you actually go back to the beginning. That's where, if you look at the number 2 going down, you go ahead and reevaluate all those phases again. And of course, as you're doing that, you can pretty much cross-reference the first pass or the first prototype that you develop. So you kind of like refer to, hey, let's see where we went wrong with this, and we're going to go ahead and try to fix our mistakes. And you can keep going. I only have 4 prototypes listed, but you can just repeat it if necessary. And these are the phases of the triangle model. Or excuse me, it should be the diamond model. You gather requirements from the client. You get specifications from the client, and you do a risk analysis to see if this is feasible or not. And once again, it should be diamond model. The prototype is when you actually design. You take all those requirements, specifications, you develop a system out of it. And the test phase is when you actually test it. And release is when you actually release the system to the client. And the reason why I called it the triangle model, because that's what I actually started with, and I took that and turned it into a diamond. So that's why I left the triangle in there, and I forgot to change it. And so requirements. user requirements. Okay, so what we're going to do with this is, sorry for that, we're going to actually apply this model for the virtual lab. So the requirements phase will be requirements was research ideas for people who interact with robots. So basically we're taking what the NRI wanted, which was just basically the research to increase scalability of people interacting with robots. So that'd be the requirements. And then the specifications would be, we're going to develop a virtual lab. So we're going to get all the specs to build a website. Like we use WordPress, and we had Oracle databases and things like that to develop the interface to facilitate users with the robots. And for the risk, we want to see if there's any risks involved. If there's enough money involved with this. The security is a big thing. We want to make sure we get that all straightened out. Is this going to take too much time, or the requirements too early or too late, and so on. And for the prototype, this would be the website, the social media, the database, and so on. And then for the test, we actually test the lab to make sure that everything is interfaced, the test accounts interface with the robots correctly, and the data stored correctly, and test security, make sure all the doors have the access cards, all the security cameras working, and things like that. And then once that's all taken care of, we can release the lab to the client. And I'm going to talk a little bit about the projects teams. There's a social media, security, web development, and server. And the last two I bolded are database and project management, because simply those are the teams that I was involved in. And for the database, for the virtual lab, it's going to basically track the accounts, user accounts, the scheduling. So when a person requests time to interact with the robot, the database will store that information. And we're also going to have the database track social media users, and also going to track lab requests or resources that the user wants. And this is the table we came up with, the ERD diagram. And simply it starts with the user table off to the left. You just get basic information from the user, and then from that, when they do a lab request, that lab request table will pull in information from the lab schedule, the employee records, sensor resources, environment resources, and the robots. It's going to consult those tables and pull it into the lab request table, so that way the user can keep track of all these things, like what sensors they use, what time they scheduled the robot, where exactly this robot's going to be, like in the water or in the on land. And of course we have the type of robot that the client requested. And of course the user can put their social media info in that table. So that's the way we track the social media users. And of course you have a lab schedule where it has all the information that's needed to create a time slot for the user to interact with the robots. It's like time and the date. And of course we have the user ID and lab request ID, so we can keep track of what time slot is for who. And finally, the project management team is what I'm involved in as well. And what we're responsible for is we're preparing the project management document that will be submitted to for the NRI committee. And this is basically going to have we're going to have our work breakdown structure. It's going to have a Gantt chart, and it's also going to have a budget with the total cost of everything that we put together, from all the access card readers and web cameras to the cost of the Oracle database, from even labor costs and things like that are all going to be included in this project management document. And of course, well, there'll be a Gantt chart on there as well, kind of show, the time, how long it'll take for each of these things to progress during the project. So this is the presentation. I hope you enjoyed it, and thank you very much for watching.